This is a short introduction to dative covalent bonds. Okay, so dative covalent bonds, they're sometimes also called coordinate bonds, and they're just very slightly different to other covalent bonds. Now, a dative covalent bond is where both electrons are from the same atom. So you're used to covalent bonds being shared pairs of electrons, and normally the ones you've met so far will have been one electron from atom A and one electron from atom B, which is why we draw a dot and a cross. So usually we'll have A and B form a bond by sharing the pair of electrons, and you've got a dot and a cross. If you've got a dative covalent bond, both of the electrons are from the same atom. So it's either two dots or you can draw two crosses, but they're both from the same one. Once that bond has formed, there's no difference in strength between these two different bonds, and there's no difference in length, there's no difference in reactivity. So it's not that this bond is more likely to break and react than this one. Once they've formed, these are now exactly the same. So it doesn't make a difference where the electrons have come from. As it were, the atoms can't tell where they're from. Okay, so there are some instances where you get dative bonds that occur commonly and pop up in the exams a lot, and it's just useful to know those ones. So one of them we might have is if we've got water. If we think about water, remember we've got, these are normal, as it were, covalent bonds. So these are a dot and a cross. Oxygen's in group 6, so 1, 2, 3, 4, 5, 6. So the oxygen of water has got two lone pairs. If then I've got a hydrogen ion, hydrogen atoms have got one electron. So if it's a H plus ion, it now has no electrons. And to have a complete outer shell, for hydrogen, the first outer shell is just the first one, so just needs two electrons to complete it. And here I've got oxygen, which has some lone pairs, so there are some electrons here. So what happens is one of the lone pairs forms a bond to that hydrogen ion, which is H plus. So this is my dative bond here, where I've got my two dots. Now notice that this side of the equation has got a charge of +1, i.e. we've got one more proton than we have electron. This side of the equation must also have the same charge. So whenever you've got an equation, the charges either side of the arrow have to be the same. And again, so we've still got one more proton than we have electron, because we didn't add any electrons, we didn't add any protons, we just kind of rearranged them a little bit. So to show this is an ion, you have to put square brackets around it and put the charge of a plus. Okay, so this is, to write it another way, H2O plus H plus. And now we've made H3O plus. Occasionally, to indicate that we've got a dative bond, we might draw an arrow instead of a line. So the line is your normal dot and a cross, but this pair of electrons from the oxygen was pushed towards the H plus, so we sometimes draw an arrow to show a dative bond. Okay, to show, and the arrow starts from where the electrons are and points towards where they're going. There are various different other examples that you might come across. So a similar one to this would be ammonia can react with H plus to make an ammonium ion. Remember, it's really important that you know which of those is which. So ammonia is NH3. You've got a lone pair on the nitrogen, and that can be donated to the H plus. So that's another similar example to that. You can get slightly different ones without. It doesn't have to be a H+, which is accepting the electron. So I can have carbon monoxide is an interesting one that's worth knowing. So that's what carbon monoxide looks like. So 2 normal covalent dot cross bonds and 1 dative bond. So if I were to fill in my dots and crosses, the normal lines are just 1 dot and a cross, but the arrow is 2 of the same types of electrons, so 2 dots, and I know because my arrow starts at the oxygens that these electrons come from the oxygen. So 1, 2, 3, 4, 5, 6, and if I check my carbon, it's in group 4, so 1, 2, 3, 4. Okay, so dative bond here, and the reason for having this dative bond is that then each atom has 8 outer electrons. So if I count up the carbon, 1, 2 of its own, plus 3, 4, 5, 6, 7, 8, because it's sharing those from oxygen. And oxygen here, 1, 2, 3, 4, 5, 6, 7, 8. So every atom has 8 outer electrons through the sharing of electrons. There are other examples, and you may well do some of those in class.